Let us start the class. We are into Biot Savart law, and we are dealing with magnetic field due to current. And we had done some cases in the last class. Do we remember those magnetic field due to the straight wire cases? Yes or no? We had done general wire, general straight wire, and from there we had derived the equation for different types of combination, and I had given you a sheet where I had asked you to solve the questions. Have you done those questions? Have you tried those questions? Yes or no? Did you get that sheet?
Sir, we didn't get those sheets, sir.
No one got that sheet?
No, sir. No one got this.
No, sir.
Okay, can't help it. Let me give one or two questions on that sheet and let us try to solve it. This is the first question that comes. That is question number 2 from the sheet. You have to find a magnetic field at the center point O. I'll give you 2 minutes. Solve the question. So how are we supposed to do this? Remember, all the wires, they are coming from infinity and they are going back to infinity. I hope you understand this. This is the first wire. What is the magnetic field due to this wire?
0.
0. Well done. This is the semicircular wire. What will be the magnetic field due to this semicircular wire?
Mu naught I by 4 pi r into pi.
So mu naught I by 4r. Yes or no? And what will be the direction?
Outside.
Very good. What will be the magnetic field due to this wire?
Mu naught I by 4 pi r.
Mu naught I by 4 pi r. Very good. What will be the direction?
Outside.
Well done. So whatever answer matches it, that is our answer. We got this, everyone?
Yes, sir.
Well done. Come the next two questions. I am putting both the questions on the screen. These are both the questions on the screen. I'll give you 2 minutes to give me the answer fatafat. So, what is the answer for the first one? Magnetic field due to this wire and magnetic field due to this wire. They will be same, yes or no?
Yes, sir.
And you can see they are cancelling each other out, yes or no?
Yes, sir.
So the answer for the straight wires is 0, only the curved wire remains, and the magnetic field will be mu naught I by 4r and it will be coming out, yes or no?
Yes, sir.
Let us look about the next one. Magnetic field due to this wire will be how much? This point O. It will be mu naught I by 4 pi r, yes or no?
Yes, sir.
And the direction would be out or
Outside,
inside?
sir. Outside.
Well done. Magnetic field to this wire will be same, mu naught I by 4 pi r. Direction will be
Outside.
Inside, sir.
inside. So basically these two fields are going to cancel each other out. The only part that remains is this, mu naught I by 4 pi r multiplied by pi by 2. Yes or no? Yes or no?
Yes, sir.
So the answer will be mu naught I by 8r. No option matches this. Doesn't matter. Maybe a misprint. So the answer will be mu naught I by 8r. Do we understand this? And it is going inside or outside?
Inside, sir.
inside, sir. So that is the answer. The option is given wrong. Don't worry about it. It happens. Next one. Next two. These are the next two. And I'll give you 2 minutes to solve the next two. Once we get this, then I will move on ahead. These are the next two. Find out the magnetic field at the center. So how are we supposed to do this? Magnetic field due to this wire and this wire, they are both same, yes or no?
Sir.
Mu naught I by 4 pi r. You just have to see the direction. Due to this wire, it is going inside.
Inside of.
And due to this wire, it is also going inside, yes or no?
Yes, sir.
So they will get added up. So the answer will become mu naught I by 4 pi r plus 4 pi r is 2 pi r, and it is going inside. Because of this circular wire, it is also going inside. So mu naught I by 4 pi r multiplied by the angle is 3 pi by 2. It is also going inside. So the option that matches is, I think, option number C. Yes or no?
Sir.
So you have to just look at the direction. If you understand the direction, everything is simple. What about this one? Because of this wire, it is 0. Yes or no? Because of this wire, it is mu naught I by 4 pi r, and the direction is outside. Do we understand this? Because of this wire, it is mu naught I by 4 r, and the direction is also outside. So which? Not 4 r by 2 r. 4 pi r multiplied by 2 pi. So which option matches? I think option B matches, and option B happens to be the answer. Everyone understands this? Yes or no? No, yes. Huh?
Yes, sir.
Everyone got this?
Yes, sir.
Then come these two. I'll give you 2 minutes to give me the answer of these two. So how you have to do this? This is a straight wire. The magnetic field due to the entire circuit is going inside. Yes or no? I think one is inside and one will be outside. The magnetic field due to the entire thing is going inside. Due to this wire, it is mu naught I by 4 pi r. Remember, r is not r here. R is, you have to find out this length. That will be r cos phi. Yes or no? Yes or no? We understand this?
Sir.
Into sine phi plus sine phi, it will become 2 times of sine phi, and the field is going inside. Because of this, it will be mu naught I by 4 pi r, and the entire angle is 2 pi minus 2 phi. So the only option that matches is option A. Do we understand this?
Sir.
Yes or no? Then for this system, this wire magnetic field is 0. This wire magnetic field is 0. Because of this wire, it is mu naught I by 4 pi. Radius is A. The entire angle is 3 pi by 2, and it is going inside. So cross. For this wire, it is also going inside, but the answer is mu naught I by 4 pi b into 3 pi by 2. Do we understand this?
Yes, sir.
Everyone is understanding or just saying yes sir, yes sir, yes sir, yes sir? Huh?
No, sir. Understanding.
Girls, I don't hear your voice. What happened? Everything okay?
Sure.
You are understanding or just Going with the flow. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Once explain second question, sir.
Dekha, see? As soon as I ask, doubts come. Which question? Which second? I have done so many second questions.
Second.
Which second? This one.
In this second, sir.
Which part you did not understand? Which part? This blue one or this yellow one? Which one you did not understand?
Yellow.
Yellow. Yellow, dirty fellow. Yellow is also arc of a circle. The radius of this circle is B, and the angle of this circle is pi by 2, 90 degrees. I just put it in the formula. Radius as B and angle as pi by 2. We understand this?
Yes, sir.
Pakka, sir?
Pakka, sir.
Oh, Kacha wala pakka, sir. Your pakka is dangerous. Everyone got this? This sheet is already there with you. I will ask. I'm just calling up. Lots of questions are there. 28 questions are there. I have done almost all of them. 2 or 3 are left, which you can do at home because I'll have to do them. I'll do them. These two. The next one. I have to move on to different sets of questions. I'll give you 2 minutes to do this. So you make the direction like this. The current is coming from here, pink one. Then it is going like here, blue one. And then it is going out here like this. The direction of the arrows of current is given ulta. So you just make it like this. Okay. Okay. Huh? So how we are going to do this? Magnetic field due to this pink wire is mu naught I by 4 pi r. Yes or no? And the direction would be inside. Magnetic field due to this wire is mu naught I by 4 pi r and the direction is inside. Magnetic field due to this wire is mu naught I by 4 pi r into the total angle is 270 degrees, 3 pi by 2, but this will be outside. So you see, in the outside sense, it will be option number A. Do we understand this? Yes or no?
Yes, sir.
Huh?
Yes, sir.
Pakka na, sir?
Pakka, sir.
This wire magnetic field is 0, this wire 0, this wire 0, this wire 0. This wire is, the current will go doing like this. Yes or no? Mu naught I by 4 pi into r into theta. And the direction would be inside. Do we understand this?
Sir.
Due to this wire, mu naught I by 4 pi, the radius is 2r and the angle is theta. But the direction would be outside. Third wire, mu naught I by 4 pi into 3r multiplied by theta, but the direction is inside. Do we understand this? Yes or no? No, yes. Oh, this has gone above our head saying bye-bye.
Understood, sir.
Bye-bye. Then you can find out which field is more. I think inside field will be more. So you add the inside field and subtract the outside field and you will get your answer. Yes or no? No, yes. Huh?
Yes, sir.
So you will get what? 6 minus 3 plus 2. 6 minus 3 plus
Option A.
Option A. Yes, option A. That is correct. Option A. Everyone understands this? Huh?
Yes, sir.
Sir.
पक्का ना सर?
पक्का sir.
पक्का वाला पक्का?
Pakka, sir.
Pakka, sir. Your pakka is dangerous, sir. Then some more questions coming up. The more the question that you do in this, the better you are going to be. This is the diagram that comes on your screen. Current flows due north in a horizontal transmission line. Magnetic field at point P vertically above it is directed in which direction? And the answer is fast. Huh? A, B or C?
C.
C, sir.
Pakka na sir?
Yes, sir.
C, sir. Well done, sir. We move on to the next question, sir. And in the next question, sir, what you must understand, sir, is that these are infinite wires, sir, but they are shown as top view of these wires. Up till now, the infinite wire was placed like this, or placed like this, or placed like this, or like this. It was in the XY plane. Now the infinite wires are placed like this, coming out of the board. And you see the top view. Do you understand what do I mean by the top view? You're seeing it from here. This is an infinite wire. Do you understand this? Huh? If the wire is like this, you're not seeing it from here. You are seeing it from here. Do you understand this? Not from here, but from here. Do you understand this?
Yes, sir.
So these are two infinite wires. Find the position of the point B where the magnetic field is 0 because of this current distribution. One wire has 5I and the other wire has 2I. Both the wires are infinite, separated by a distance of 6 centimeter. You have 2 minutes to give me the answer and stay happy. Both the wire carry current which is coming out of the board. The answer is C. It is correct. Now you must understand, and similar question came in 2 years back. You must understand that both the wires are, the current is coming out. If I call this wire as pink wire, current is coming out. If I call this as green wire, current is coming out. The magnetic field, let us say that the distance is x from this wire. Distance is x from this wire, and from this wire it will become 6 minus x. Now magnetic field to the pink wire will be going in the upward direction, yes or no? And magnetic field due to the green wire will be going in the downward direction. That means the point where the magnetic field is 0 is going to happen between these 2 points, yes or no? Between the wires. What is the value of magnetic field B1? Magnetic field B1 will be mu naught into I. How much is I? I is 5I
I by
divided by
2
2 pi x. The value of magnetic field B2 will be mu naught into 2I by 2 pi into 6 minus x. You just equate and you will get the value of x as 12 by 7 centimeter or meter or whatever. We understand this? Yes or no? No, yes. Huh? Now this has
Yes,
gone
sir.
above right, saying bye bye, bye bye, bye bye, bye bye.
Understood, sir.
I'm just going through that previous year stuff. I think there is a question that I saw sometimes back. That was on this concept. Let me see if I can get that question for you. And I hope that you can give me the answer for this one. Oh. Where is that question? Hmm. This was the question actually. Now again, you must understand that we have still not covered the part of magnetic force, but this question is simply a question. This is the question that came in your JEE. Don't look at the diagram. The diagram might be confusing. Two wires A and B carrying current I1 and I2 as shown in the figure. The separation between them is D. Same question. The only thing is the question that we were doing, we were looking at the top view. This is the side view. The separation between them is D. A third wire C carrying a current is to be kept parallel to them at a distance x from A, such that the net force acting on it is 0. What are the possible values of x? Now, we don't know what is the magnetic force. We still have not done, because that is the next chapter, magnetic force. But right now, what I can tell you, magnetic force will be 0 if magnetic field is 0. Do we understand this? Do we understand this?
Yes, sir.
Magnetic force will be 0 at the point where magnetic field is 0. We get this? So you have to find the point where magnetic field is 0. Remember, look at the direction of current. This one is having current in this direction. This one is having current in this direction. I'll give you 2 minutes to solve this question. Everyone understand the question? Yes or no? No, yes. Huh? You understand the
Yes,
question?
sir. Yes, sir.
Solve it. I have changed the question in such a way that you have to find out the point where magnetic field is 0. Okay?
Sir, sir, option D.
Option D. How did you get option D? Okay. Yes.
Option C, sir, not D.
Option C, sir, not D. Okay. Now, you must understand here that both the wire carry current in the same direction. Yes or no? In opposite direction. Yes or no? Do you understand that both the wires carry current in the opposite directions?
Yes, sir.
What I wanted you to understand, where will the magnetic field zero? Will it be zero between the two wires, or will it be zero at points outside the two wires? That means what I am going to ask, can the field be zero in this yellow zone, or will the field be zero outside this yellow zone? This yellow zone is the inside part, the other one is the outside part. Where is the field going to be zero? Yes. Where is the field going to be zero? Outside. So it can be zero here, or it can be zero here. Now, on what factor does it depend whether it's zero here or zero there? Zero here in the region 1 or zero here in the region 2? If I1 is greater than I2, then it will be zero where? It will be zero in which region? Region number 2, because okay, that is what you have to understand. If you understand this, then the question becomes simple. Let me call that distance as x. I'm thinking about region 2 right now. So magnetic field created by the first wire number 1, will be mu naught I1 upon, if I call the distance as x, 2 pi x. The magnetic field due to the second wire will be mu naught I2 by 2 pi into x minus d. Do we understand what I have written here? Because the point is here somewhere. So if I call this distance as x, the distance from the second wire becomes x minus d. We understand this? Yes or no?
Yes, sir.
So from here you will get the value of x. What is the value of x that you are going to get? What is the value of x that we are going to get? I1 d upon I1 minus I2. Yes or no? Or I2 minus I1? Or I1 plus I2? What? This is what you will get? Yes or no? Yes or no? Second case, if I1 is smaller than I2, then it will happen in region number 1. Region number 1. Magnetic field due to this one will be mu naught I1 upon 2 pi x. That does not change. But for this one, it will be mu naught I upon 2 pi x plus d, because in this case the x is here. Are we able to understand this?
Yes.
Yes or no? No or yes?
Yes, sir.
What is the answer we are getting? I think in that case you are going to get I1 into D upon I2 minus I1. Yes or no? No or yes? Yes or no? No or yes?
Sir.
Yes, sir.
So which option out of these is correct?
And D, sir.
Do we understand this? How we have done this?
Yes, sir.
Sir.
Okay. This is the next question. I'll give you 2 minutes to solve it. I hope you understand how these 4 wires are. Just to help you out, I will give you a 3-dimensional view also that might help you in understanding it more nicely. So now, after taking a deep breaths, I hope you are able to understand how these things are. And we are looking from here, the diagram that is shown to you is looking from here. Do we understand this? Yes or no, no or yes?
Yes, sir.
Now, can I have the answer, sir? What will the resultant magnetic field at the origin due to 4 infinite length wires if each wire produces a field B at the origin? And answer is definitely not 0. I told you about the case where I heard someone say, wherever there is 0, mark 0 because 0 is the answer. That is the most stupid video that I ever saw in my life. That was the first and the last video I saw. Yes. Shall I do it for you or shall I wait till eternity? That answer is coming from somewhere.
Good,
Somewhere.
sir.
Coming or not?
Do it, sir.
Yes, sir.
So the question is already solved here. You can see the value of magnetic fields. I1 wire and I2 wire both will produce field in this direction. If I draw it on the original diagram, I1 is outside, point is here, I1 is outside, I1 is outside, point is here, it will produce field in this direction. Yes or no?
Yes, sir.
I3 is going inside, it will also produce field in the same direction. So the field in the red direction becomes 2B. Do we understand this? Yes or no? No or yes?
Yes, sir.
Then what remains? Nothing remains. The green wire, dung 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 dung. Where in which direction they are going to produce field? Dung 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 dung. So this field also becomes 2B. The problem is one field is along x-axis, the other two fields are along y-axis. So the net B becomes root over a square plus b square plus 2ab cos theta. That formula, 2b whole square plus 2b whole square ka root, and the answer that we will get is a very nice, very wonderful 2 root 2b. Do we understand this, or this has gone above our head saying bye bye? Bye bye. Bye bye.
Understood, sir.
Bye bye. Bye bye. I'm going bye bye. Huh?
Understood, sir.
Understood, sir. Your understanding is very difficult to understand, sir. Okay. I hope we got this.
Yes, sir.
Everything is okay, no?
Okay, sir.
Okay, sir. Your okay is dangerous, sir. You say okay, sir, in the next question, it becomes not okay, sir. Okay. Now remember, the wires are coming from the Z axis. This is the next question, and I can't show you the diagram because in the diagram everything is given. So I will draw my own version of the diagram, and you have to find the magnetic field at this point. The point P is given as here. One of your infinite wires is here, I. The other infinite wire is here, I. It carries current in the cross direction. This question, similar question, same question has come in JEE Advanced. This distance is A. This distance is A. And this angle is given, both the angles are same. The angle is given as T. No, angle is not given, sorry, angle is not given. Let me make it. Let me make this distance also as A. All the distances are A. No, sorry, distance is given. Because there is an R coming into the picture. This distance and this distance is R. There is an R coming into the picture. Pi R square, I just saw it. You have to find the magnetic field at point P. One wire carries current like this, jing 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 jing. The other wire carries current like jing 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 jing. Wing, 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 like this. And the point P is here. You have 2 minutes to show your talents, else I have no choice but I will have to solve it. Let me solve it. How am I going to solve it? Any idea? Anyone got anything? Yes or no? No, yes? Hmm?
No, sir.
No, sir. Okay. Let me make the question simpler. When you find out the magnetic field at this point O, what will be the magnetic field at this point O? If I call this as the pink wire, where will the magnetic field due to the pink wire go? Magnetic field due to the pink wire? Where will it go?
Inside, sir.
Huh?
Inside.
Take deep breaths. Current is coming out. Current is coming out. Magnetic field is perpendicular. We have done so many things. Take deep breaths. It will come in this direction. Yes or no?
Yes, sir.
It's not inside outside. It is right. Don't say inside outside. I'll get a heart attack. Magnetic field due to this green wire. Current is inside. So where it will go?
Opposite direction.
Take deep breaths. Deep breath is good. So both of them are adding up. So the answer will be mu naught I by 4 pi r multiplied by 2 mu naught I by 2 pi r multiplied by 2 mu naught I by pi r pi a. Do you understand this? Understand this?
Yes, sir.
पक्का ना सर?
Okay, sir.
Akka, sir.
बिल्कुल पक्का ना सर? नो कच्चा, ये ओनली पक्का ना?
Yes, sir.
जो पक्का is dangerous.
Yes, sir.
ये पक्का is more dangerous than जो कच्चा. If you remember, I told you current due to an infinite wire is moving in circles. Magnetic field due to an infinite wire is moving in circles. Do we remember this? This wire ding 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 ding. Remember this? Huh?
Yes, sir.
Good. If the wire carries current in the outward direction, the magnetic field at this point will be going like this. Yes or no? Twee, twee, twee. The magnetic field at this point will be going like this. Yes or no? Magnetic field at this point will go like this. Yes or no? Magnetic field at this point will go like this. Yes or no?
Yes, sir.
The point is here, my dear friends. Where will the magnetic field go? Dung, 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 dung. Dung, 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 dung. Yes or no?
Yes, sir.
Now, mentally superimpose this circle here. Where does the magnetic field due to this wire go? No idea? Then get idea. It will go like this, perpendicular to this line. Do we understand this, or this has gone above our head saying bye bye?
Yes, sir.
Understood, sir.
Then, my dear friends, if I call this wire as wire 2, field is going, current going inside. Can you tell me what will be the direction of magnetic field created by this gentleman at that point? You need to take deep breaths. That will help. Yes. Will it go like this? Ding, 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 ding. Ding, 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 ding. Will it go like this? Yes or no?
Yes, sir.
That's your answer. Because B1 and B2 are same, sir. If I call this current as, if I call this angle as theta and theta, I can resolve B. Both are same actually, because the current is same and the distance is also same, my dear friends. So this B ka this component and this B ka this component will cancel each other out. The net field will be this B ka this component plus this B ka this component getting added up. If I call this angle as theta, this is plane geometry. I can't help anything. This angle would be, let me take out this P. This angle would be 90 minus theta. Yes or no?
Yes, sir.
That is your answer, sir. So your net magnetic field, well, you can do it this way, or both the field are at 180 minus 2 theta. You can apply a square plus b square plus 2ab cos. But I will do it this way. B net will be 2 times b sine theta. Everyone has understood this. Cos of 90 minus theta is sine theta. 2 times what is the value of b? B is magnetic field due to an infinite wire, mu naught I by 2 pi. The distance of the point is R. Do we understand this?
Yes, sir.
Yes, sir.
What is the value of sine theta? It is A by R. Yes or no?
Yes, sir.
And you have your answer, sir. Your answer is option A, sir. You understand this, sir, or this is going number our head, sir? Saying bye bye, sir.
Understood, sir.
Understood, sir.
So wherever you have infinite wire and they ask you current at different points, take a deep breath. Understand, remember that the magnetic field is moving in ding, 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 ding circles. So you join the point, you join the wire with the point, the magnetic field will go perpendicular. This magnetic field is perpendicular to dl cross r, dl cross r, dl cross r, dl cross r. Do we understand this? Huh?
Yes, sir.
Sir.
Or go on about it, saying bye bye. I'm going, don't worry about me. Huh?
Answer, sir.
पक्का ना सर? कच्चा वाला पक्का, पक्का वाला पक्का.
पक्का, sir.
पक्का वाला पक्का. Your पक्का वाला पक्का is more dangerous than जो कच्चा वाला कच्चा. Okay, so hoping that your कच्चा वाला पक्का and पक्का वाला कच्चा and पक्का वाला पक्का and कच्चा वाला पक्का is good. This is the next question on your thing, and I need the answer fast. Remember, these are all questions taken from Herodo. Ding 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 ding, and these are very good diagrams. I found them in a sheet of mine which I had made. I don't know, eons ago. This was probably I made in the year 2002, 3 something. I put in a lot of effort. I can see that. This is ding 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 ding. I found it in an old hard drive. I was going through the hard drive. Oh, found this. I took it out. It's helping. You have to find the magnetic field at point 2. And I hope you understand how the current is coming. You understand how the current is coming? It's in 3 dimensions. You understand? Huh? This current is coming from infinity. We understand this? Coming from z axis. We like this. Then it is turning like this. We. Then it is going like this. We. Then we. Then we. The last current goes like this here. It's coming out of the board. Let's see who gets the answer for this one. You have 2 minutes to show your talents. Else, I am always there. Let me solve it for you. Anyone is there?
Sir.
No one got any answer? Okay. What is the field due to this wire? Tell me fast. Field due to this wire. Mu naught I by 4 pi r. Yes or no? Semi-infinite wire. Yes or no?
Yes, sir.
What is r? How much is r? 3a. Yes or no? Yes or no? No, it's not. It's not 3a. It's not 3a. I think it is 2a, right? The distance from the center O is 2a, not 3a. We understand this? And the field due to this wire will be going down. Going down means it will go along minus j. This field will go down. Do we understand this? I'm not getting any voices. Do we understand this?
Sir, how to a?
How to a? That is what I am also thinking. I have to find out the distance from this. I think which point is given as what. It's difficult to understand. What I have assumed is, okay, I think this point would be A, this point would be A, this point would be 2A, and this point would be 3A. So it is not A. Then it will be 3A minus 3A by 2. It will be 3A by 2. 3A by 2. Now it is correct?
Yes, sir.
Okay. Then let us find out the magnetic field due to the green wire also. Green wire, it will be A by 2. Yes or no? Mu naught I by 4 pi into A by 2. Yes or no? And this field will also go down minus J. Now let me come to the field due to this wire. This wire is the blue wire. Mu
If the pink
naught.
wire, it's not A, sir, it's 2.
Yes, beta?
Not I, 2 by 4 pi 3A, sir.
Yes, 3A. 3A by 2. Now correct?
Why we are having A on numerator?
Okay, I have written A on the numerator. Sorry. I am making mistake. Now correct?
Okay, sir.
Good. I am not okay. Due to this y, it will be mu naught by why I'm writing 4 pi. Semicircle, so pi and pi cancel. 4 into the radius of the circle is, array, what is happening? Everything wrong is happening. 4 into 3a by 2. Yes or no? Now remember, this field is coming out of the plane. So the answer would be K here. Do we understand this? Field due to the blue wire is coming out of the plane along the K axis, Z axis. The field due to this yellow wire, field due to this yellow wire will be mu naught I by 4 into the radius of the wire is A by 2, and this field will be going inside minus K. One field, these two fields are along minus J, so they will get added up. This field is along K and this field will is along minus K. They will get subtracted. Eventually, both the fields are perpendicular to each other. That will give you your answer. So what is that you are going to get? If you add the pink field and the green field, how much you get? That will be along minus J. That will be mu naught I can cancel this 2 here. So this is 2, this is 2. So I can write mu naught I by, oops, why I'm using so fancy things. Let me use a black one. Mu naught I by 2 pi A into 1 plus 1 by 3. So I will have mu naught into, again I will get 4. So 2, 3 pi A into I. This will be the field along minus J. I hope I have not made a mistake in calculations. I make mistakes in calculations. Then I will have to subtract this. This is again going to be 2. This is again going to be 2. So I can write mu naught I by 2a, and I subtract 1 minus 1 by 3. So I will get 2 by 3, 2 and 2 will cancel. So mu naught I by 3a I will get here. Now I have to square them and add them. Square them and add them. These two options are definitely not coming. This option is dimensionally wrong. The only option that is correct is this one. In fact, you did not have to do the question. You could have done it by dimension analysis. 4 minus pi square cannot come because this is y square plus z square. And then the only option which is dimensionally correct is this one. Are you getting that answer or are you not getting that answer? I think you will be getting that answer. We understand this, yes or no?
Yes, sir.
Anyone got this answer? Anyone got this? Yes or no? Shall I give you one more? Everyone is ready?
Yes, sir.
Remember, when these wires are coming out and in, you have to be careful in understanding their directions. If you understand their directions correctly, you should not make a mistake. This question is relatively simpler compared to that. Find out the magnetic field at the center O. And here the radius problem is not there, so you should get the answer quickly. So there will be two fields, and that would be perpendicular. Minus can never come in this universe. So let us remain in this one, which is a good one, 4% of which we see. It's a good universe. Trust me on that. Let us see. The pink field is how much? Mu naught
I by 4
Divided by 4 pi r.
pi r. And the direction will be towards minus x-axis. Yes or no?
Yes, sir.
Yes or no? So minus x means minus I. Field due to the blue wire. Mu naught I by, oh, the blue wire is
0, sir.
zero. Sorry, I'm wandering in some other universe where blue wire creates field. Then this field due to this one, this is simple. Mu naught I by 4 pi r into pi by 2,
Pi by 2.
and the direction is inside minus k. And these two fields are square. I mean, one is along minus x and one is along minus k. This square plus that square. The only option which is possible is this if all the options are written correctly. Yes or no? No, yes. Huh?
Yes, sir.
That is
Once
the answer,
check
sir. We
option
have
A, sir.
done. Yes, sir.
Option A is once check, sir.
Yes, I think one
Both
eye
I.
is, one eye is there. That's why I said, no, if this is correct. That's why I said. Misprint. Do we understand this or this has gone above our saying bye-bye?
Understood, sir.
The sheet is there. I think I got a message from Raghu sir as well. I think the sheet would be there right now.
I got it, sir.
Yes.
In Tarnaga, we didn't got, sir.
Take it
In
easy.
simple, we got just now, sir.
See, as I said, no? Even though I can't see you, I know what's happening there. You'll get it. Do this question once again. These many questions are much more than enough that you will ever require in this life, in this universe, or in any other universe. So I'll see you in the same universe tomorrow, and we'll go ahead and we'll try to wind up. We will have to wind up this magnetic field by tomorrow. In all likelihood, we will wind it up. Only one thing is left: Ampere law. and some more questions which I will give you. I will not solve them. I'll just give you the solutions. I'll just give you the answer. You just have to remember them. So I will collect those and I'll give them to you. And then we will wind up with Ampere law probably by tomorrow. And in Sunday's class, if we get Sunday's class, we start with magnetic force. We have no time left. So I'll see you tomorrow. Take care. God bless all of you. Bye bye.